So ICP-4 for deep learning, the first one is to follow the instruction below and report how the performance changed, and visualize the graph and loss with the tensor board and predict the 4 image of the test data and then print the actual label of the 4 images. So coming to ICP-4, the first step to do this question is to import the libraries like NumPy to do the operations on numbers and keras for the machine learning stuffs. For example, for dataset, we use keras.datasets, model, keras.models, etc. So we have used the CIFAR, CIDFAR CIFAR dataset. So the CIFAR dataset contains the CIFAR dataset is an established computation dataset having the set of images. So it has the train and the test dataset and having the train labels. The label classes are like aeroplane, automobile, bird, cat, etc. So after loading the dataset, we store the train and test dataset into two variables, that is xtrain and xtest, as the float 32, and divide all of them by 255 for the normalization, and use a categorical function, that is np utils, for making into categorical value. Two categorical function from utils library. What it does is it converts a class vector to binary class matrix. After doing that, we create a sequential model on the dataset which we have created. I think before sequential model, whereas sequential model is a linear stack of layers. So here we have certain layers, like the first one is to add the convolution input, that is 32 feature maps with a size of 3 cross 3 and a rectifier activation function, and with a dropout layer of 20%. So if you see the rectifier linear ReLU, that is the rectifier linear is the mostly what it does is the ReLU function returns 0 if it receives any negative input, but for any positive x it returns that value back itself. So it can be written as any input, it gives max of 0 comma x. So if you put -2, it's going to be 0, and if you put +2, it's going to be +2 itself. And coming to dropout layer, the dropout to ignoring units during the training phase. We ignore the units which are not necessary for the model. So first one is to add 32 features as we mentioned here, and as 3 cross 3 and dropout of 20%, that is 0.2. The next one is to create a layer same with 32 3 cross 3 ReLU, but here now we add a max pool instead of dropout. So coming to what is max pool. Max pooling is a sample based discretion process, that is to, let's say we have a pictorial representation like this, we make it to max pool. That is, if we see the first 4 square 20 is the highest value, the second 4 squares 30 is the highest value, like that. So we could reduce the number of data points, that is from, like for example, if you take 224 in cross 224 cross 64 to 112 to 112 to 64, which is very reduced number in feature, and that is called downsampling. So now you could see 32 3 cross 3, again adding 64 3 cross 3 and 20% of dropout. Now 34 3 cross 3, max pooling of 2 cross 2, 128 3 cross 3 20% dropout, and 128 3 cross 3 and max pool 2 comma 2, and adding a flattened layer. So the flattening is, if you have pooled feature map, we make it into flat, like making 3 cross 3 to 9 cross 1, again adding a dropout layer, again 1024 and 0.2 dropout layer, making the fully connected layer. The fully connected layers, every neuron in one layer to every neuron in another layer, that is called as fully connected layer. And now we visualize the graph. You could see the parameters here, and at last we got 50